We are Pierre, Lisa, and Tiller, now sailing in French Polynesia in the South Pacific. Subscribe to join our adventures, and we always appreciate your comments to help us make this channel better. We left the Tuamotus to sail to the Marquesa Islands, and we arrived in Teahuay Bay in Nuku Hiva. In our last episode, we were in Nuku Hiva and received some friends on board, and then we sailed to Tawata to enjoy some beautiful clear waters. From Tawata, we sailed to Hiva Oa, where there's an airport, so that our friend could return to Boston, and then we sailed to Fatu Hiva. I had an encounter with the winch leading to a fat lip on our sail back to Fatu Hiva that I'm going to tell you about here. Now, before we did all these trips around the Marquesas, we did a solar panel installation, and Pierre and I are both really pleased with the result. Welcome to BioTruck Sailing. I wasn't going to do an intro this week because I have a bruise on my lip. Here, I'll show it to you here without a little bit of makeup to cover it. So I had a little encounter with a winch, and I'm a little embarrassed about it. It was kind of a dumb accident, and I'll tell you about that a little bit later in the video, and after I talk about the solar panel installation that we recently finished. I'm also going to tell you a little bit about the Alternators that has been a project that's been going on since the Caribbean, and so this will be for our viewers who like to see all the improvements we make on BioTruck. It's a process. I mean, you don't just sail all the time. There's always boat projects, sometimes repairs, often just preventative maintenance or improvements. We finished the solar panel installation when we were in Nuku Hiva after arriving, and we wanted to get it done before we had friends arrive. We're now in Tawata, but the clips you'll see for the solar panel were taken in Nuku Hiva. We anchored in Teahuay Bay. After exploring the town, the next order of business was to finish the solar panel installation that we had started in the Tuamotus. We needed to finish the wiring and to install the panels on the port side. The main issue to overcome was the steel plate on the bimini top, which is needed to support the post, so Pierre bought some honeycomb that could go underneath the panels. In the end, we only used the honeycomb for the two panels that would cover the post. The others were glued with the sticky back, giving a minimal difference in height and not observable from above. Even with the honeycomb, Pierre had to drill out about 1 millimeter from the bimini top to make sure that the solar panel would be flush with the stainless steel cover to the post. All right, let's see what's going on here.
No, it'd be nicer tomorrow when I can remove that thing.
Yeah, because the top one's glued.
Yeah.
The other one's is just regular glue.
Just two-sided sticky tape on those, which is really easy. But the middle one, we couldn't do it because of the stainless steel plate holding the roof.
So now here in Nuku Hiva, we had to go through the same process with the port side, and then make some holes in the roof and pull the wires through so that they could be fed into the salon. Yeah, we're going to have to make the holes on that side, and that side's already done. I'm pulling. On the port side, we could fish the wire from the light fixture into the salon with no problem, as these ceiling panels come off. On the starboard side, we didn't need to use the access panel to get from inside the bimini to inside the salon, but not so on the port side. We couldn't get the fish wire through, so Pierre made the hole bigger. Once the wires were brought into the salon, they had to be taken over to the inverter through the walls without showing. The tricky part is from the ceiling and to the inverters that are behind this cushion. Our Mastervolt combis have battery chargers, inverters,
Solar panel converter.
Solar panel converters. And an input for generators. That's why it's called a combi. This is not my area of expertise, so you could hear Pierre prompting me in the background, but I do like to help pull wires and follow as the project moves along. So from the ceiling, the 2 wires went down inside the wall behind the fan where there's a space into the bathroom, and then back up again behind this panel where the inverters are, which is kept them nicely all hidden and in the conduits where all the wires are supposed to be. So got the wires in the bathroom coming from the salon in there. We will then pull them over to the salon where the inverters are through the hole right here. And we have a new solar panel installation. Check out this installation. It looks absolutely magnificent. Our current solar panels above the davits give us about 600 watts of power. And the new panels on each side will give us about 400 watts each. So we've more than doubled our solar energy that we'll have on BioTrack. On our boat, we do use a lot of power, about 14 kilowatt hours per day. We have an on-demand water heater that we use mainly when guests are on board. We have a microwave convection oven. We use induction cooking. And we each have large computer screens, and that takes a bit of power. Of course, we burn more energy when the inverter is on. We turn the inverter off when it's not needed, and it's always off at night. And Pierre's navigation computer always stays on with the anchor alarms. It has its own small micro inverter, so it can stay on without all the power in the boat being on. BioTrack has 2 80 horsepower Yanmar engines that came with alternators. They're burst alternators that are light-duty alternators typically used to charge starting battery. In our case, the engines came with 2 alternators, one 12-volt alternator and one 24-volt, because our boat runs mainly on 24 volts, and the 12-volt loads are provided by a DC-DC converter. In the original installation, the 24-volt alternators went directly to the DC distribution panel. The old alternators were 60 amps running at 24 volts. The new alternators are 185 amps at 28 volts. That means they need a regulator so that we don't overcharge. The voltage regulation is done by CAN bus communication to the BMS, which is the battery management system, and is part of the lithium battery bank.
This one is 60 amps at 27 volts, and this one is 28 volts but 185 amps. I mean, it's just completely different construction, much better cooling, much more efficient, so it doesn't produce as much heat for the same amount of amperage as this.
So, oh, I can see that the wires are a lot neater now, Pierre, down there.
Yeah, they disappeared. They used to be all bundled here. Now they go all under the strap all the way forward. And now I'm just finishing the feed for the feed and the temperature sensor for the alternator. And then the engine part, I'll put the belt on, put the tension back on, and that part will be finished. Then I just have to finish, the connecting all of the signals for the alternator controller. I've changed the cables from the alternator up, of course, to our 4-odd.
I'm making lunch. All right, my trip to the store wasn't a success. They only had 4 eggs.
I'm pushing 110 amps right now at 28 volts. And it should be pushing higher. And I know why, because I'm doing my voltage sensing here instead of at the battery.
But how does that compare with the old one?
Oh, it's like 3 times the power already. The other one I had trouble to get more than 40 amps. So I always said if the generator fails, because we only use the generator to charge the batteries anyway, we have the inverters, and then we can just use the engines. But the engines alternators that we have on it are these guys, 28 volt, 60 amp alternator, which in theory it's not too bad. A 60 amp is still about 1 kilowatt. The problem is they're built for cars, and they will charge a car battery, which only is used to start the motor, and that's it. So they'll be able to produce their output for a few minutes, and then they just derate because they get too hot very quickly. And so they cannot be used to charge a large battery bank, especially lithium-ion battery bank.
Okay, so that conversation was before we crossed the Pacific. And then our generator did fail after we crossed the Pacific. And with our induction cooking, I was really glad that we had our new alternator backup. And stay to the end if you want some extra content on Pierre talking about the BMS alternator communication. Our generator stopped working while we were at anchor in the Tuamotus. We didn't need to alter our plans, but we did need to put up with the noise of the engines when charging with the alternators was needed. So having a backup has really worked for us. The generator problem turned out to be complicated because it was a hole in the mixing elbow, which is the output of the exhaust valve, and that resulted in salt water getting into the engine. The Fisher Panda expert in Tahiti, Dominique, came aboard on a rainy day to give us his opinion.
Un petit reportage pour l'histoire.
You can see it's a tight fit in the locker where the generator is located. He said it'd be best to take the generator to his shop.
Attends, j'arrive.
So it was hoisted out and Dominique took it to his shop. Laura, I think you're best to come out of the way. She's hoping to go ashore, but it's not happening. When we visited his shop, I found it a bit shocking to see our generator in so many buckets. But Pierre ordered up an overhaul parts kit from China, and once he had it repaired and put back together within a day or two. That was really a good thing because we had planned to go to Fakarava, where we had friends flying in. Due to the rapid repair of the generator and an optimal travel window, we were able to keep our sailing plans and continue on. So Dominique, who helped us with the generator, is quite a miracle worker, and if you ever need help in Tahiti, I recommend that you contact him, and his contacts are in the comments below. Pierre's brother Jacques joined us in Fakarava, where the installation of the port alternator was completed.
So that's what I was discussing with Jacques. That's the CAN bus cable that we're going to hook up between the left engine and the right engine, and that's the little splitter, if you want, type of a thing where the power coming back from the BMS will go in this port. One port will be used for the local alternator controller, and the other will be this cable going from this port all the way across back to the other motor controller.
But why do the two motors have to speak to each other?
No, the motors don't care about each other, but the BMS does.
You do help.
Oh, trying to fix some part.
No, you did a complete install of you removed the old alternator, this one, and installed a new one. In a small place in the engine room, I was sure glad I didn't have to do that, because Jacques is a lot smaller than I am.
You're more flexible than I am.
So if you're a guest on BioTrek, get ready. So back to our time in Marquises, we could really enjoy ourselves in this remote location where we spend all our time at Anchorage with the rebuilt generator that's working perfectly, new solar panels, and 2 alternators giving us power when we're motoring or if the generator fails again. So as far as my little encounter with the winch on my lip, it's been about 5 days ago now, so it was swollen, it's still a little black, everyth's fine. Someone said to me, oh, you're lucky you didn't break your teeth. No, that wasn't the issue at all. I'm actually lucky I didn't break my arm. So what happened was I did, as usual when accidents happen, there were a number of things that were wrong. I was a little anxious. We needed to jibe. We were approaching an island quite quickly, and the wind was accelerating, and Pierre was predicting the wind to switch. And then when we decided to jibe, I was already anxious, and I wanted to roll that head sail fast. So it was also very sunny, and I was doing a no-no. I had put a blouse on, so I had some loose clothing. And sometimes we take the cushion off, by the seat so the rope doesn't get tangled as it goes in through the cleat. And so I could see the rope starting to knot, and I just reached over the winch, and that's it. With the loose clothing, so I had a loose blouse on, it got caught in the rope and my hand was pulled in. Okay, so this is a reconstruction. Usually when I'm doing the 3 speeds, I sit here, I push the button. By putting a 3-speed, you'll push this button here, and I watch to make sure. I'll often stand here and hold this rope to make sure it doesn't get tangled. I reached to untangle, and this was loose, so my arm got pulled in and my lip hit here as my arm got pulled in.
The other lip.
No, it's
This side.
oh yeah, sorry. It doesn't hurt anymore, so I can't even tell. And my arm got pulled in, my lip hit here. And you can probably imagine it better with this image where the blouse got tangled in the lower rope, pulling my arm in. That's it. Dumb accident.
No, you shouldn't be rushing. Never.
Shouldn't be rushing. Should not be rushing. Right? All right. Now, I'm the one working the button, so it wasn't the end of the world. I mean, automatically release the button. But these are 3-speed winches. I was on 3rd speed because we like to roll fast so the sail's nice and tight. And that means it takes the motor a little bit to stop spinning. And so obviously I yelled. Pierre came over. He helped me untangle my arm. I had not even any bruises on my arm, but if someone else had been working the winch and there was a bit of a delay in releasing, now that could have been a very serious accident. You may know that we also had another winch accident on BioTrek that was in Martinique. I don't remember the episode, but I will post it in the titles above. And that was when somebody got a watch strap by, again, reaching over a winch. The watch strap got caught, hand got pulled in. That was a much more serious accident. It's called a degloving, when all of the skin from his hand was removed. Luckily, everything was fine. There was no nerve or blood vessel damage. So that all ended well because Pierre was able to stop raising the main halyard as fast as possible in that accident. And we know electric winches are dangerous, and I always tell everybody on BioTrek, long hair must be tied up, no loose clothing, do not wear a watch. I always take my rings off when I'm sailing, and yet I had that really, really dumb accident. Yeah, so I will never wear a blouse again when I am sailing and handling winches, just wearing rash guards, which are tight on the wrist. We love the continuous rollers for our head sails, but sometimes the rope can get twisted. So what we do now is we use another block to make sure that the rope is kept in an orderly fashion as we're rolling the sails. We make these videos to share our enjoyment of our ocean world with you. We'd really appreciate it if you subscribe and give us a like. And if you like these videos, consider a donation to the Alliance to Cure. This is a foundation that we support. They're trying to find a cure for the disease of cerebral cavernous malformation. And you can find more information on the links in the comments below and also on our website. In our next video, we're going to be visiting the beautiful island of Fatu Hiva. Fatu Hiva is perhaps one of the most dramatically beautiful islands in all of the Marquises. And now, here's some extra content for those technically minded people who want to hear Pierre talking about battery management systems.
What's important, especially with lithium-ion batteries, is to be able to control the output of the alternator. That's the biggest issue. It's one thing to keep an eye on the voltage. Is the batteries are still, a bunch of cells in series. To build a big battery, you can't just put them in parallel because the voltage will be too low. It's not efficient. So you put them in series and mixture of series and parallel to build, the kilowatt hour that you want. And very quickly you end up having major issues because you have to control those. The new technology batteries, the new lithium-ion batteries now with a good BMS will last thousands of cycles, which is really equivalent to 10, 15, 20 years very easily. Very often longer than the life of the boat. So all of this old thing, is in the past now. It's finished, and technology has evolved very quickly in the last 5 years. But that brings back the original point that I was trying to make as to any charge source, any discharge source, also to a certain extent, but especially the charging has to be controlled. And the way you control that is just looking at the top voltage is not good enough. You'll say, well, I'm going to push so many amps, maximum amps of the device to charge the battery as quickly as I can. And then when it gets to the top, the voltage will, as it gets to the high voltage of the battery, then the amps is going to start to reduce. But that's only part of the system. And if we do that, then of course we monitor the temperature. But this is not a long-term solution at all. It's actually quite dangerous to do it this way because of what I mentioned before. You know, you're not monitoring at a cell level. So that's why it's so important to monitor at the cell level. So in this case, we have a 25 kilowatt hour battery bank, state-of-the-art. You know, Tesla cell type of technology and MC technology, which is extremely powerful, very energy dense, very lightweight, but which its own advantages and disadvantages if you want. But the point is you have to control when you're charging, and that's why having an intelligent interface is so important. In this case, it's that little box here that controls everything. And the only thing that box does is more or less, there
That's
it
for the
is.
second one. You've already installed the
Yes,
first
that's
one.
for the second alternator, which is this one. So what this guy does, basically, is it listens to the BMS of the battery. And the BMS of the battery will send you a string of characters, which is the target voltage. Right now it's asking if it's charged. In charge mode, you'll ask for target voltage of 28.6 volt and maximum amps of 600 amps. That's what this battery will accept to charge. To discharge, it will accept it down to 21 volt and a 600 amp discharge. So these are the charge and discharge cycle, the limits of this battery. And then you go down to the cell level. Right now the state of charge is at 78%. The voltage of the whole battery is at 27.4 volts, which is a 78% state of charge. And then we see the minimum cell of the whole batteries. You have 3 batteries in parallel right now, and each battery has cell blocks of 7 cell blocks each battery. And of course, these cell blocks are built with 3.65 nominal battery cells. And the minimum maximum temperature. These 2 temperature probes are taking a different place in the battery box, so that's normal. There's a small difference there. But what I'm saying is that the BMS is transmitting to the charge controller, which varies the field of the alternator, a target voltage and a target amps. And then the alternator will be following this as a target, but also monitoring this. So if the BMS detects there's starting to be a spread between the minimum voltage cell and the maximum voltage cell, it'll start to taper off the charging and let the BMS internal balancing take care of bring them back to equal. And the same thing is the temperature go up too high, it will back off the charging rate to control it. So this type of communication is extremely important in first charging the battery quickly, but not having any issues with the battery. So that's why there was a bit of research needed into finding something that would work nicely with the battery that we have and the alternator charge controller, a little bit like what we do with the charger inverters, which are being fed by the generator. So
And are we the first ones to use that alternator? Chiller. Shh. Are we the first ones to use that alternator with the MG batteries?
No. Everybody was surprised when I did the research and I found these guys that they label themselves as being the only company that is able to read CAN command from a BMS. And I tend to probably believe it. That lead is not going to last very long because the technology is actually very simple.
And again, the company that we bought this from is called American Power Systems.
No, we bought it through an integrator, Ocean Planet.
Oh, you bought it through Ocean Planet.
Yeah, which is Bruce Schwab, which is a round the world racer that I've known for years.